So I have the distinct pleasure to introduce Tracy Van Brakle, who is an expert member of technical staff for AT&T Labs for srsRAN, co-chair or key contributor within several open source projects and standards development organizations. She is the principal investigator of the NTIA PWS CIF project Accord, which stands for Accelerating Compatibility and Commercialization of Open RAN for Deployments, and the PI of the NSF DoD Convergence Accelerator Project Indigo.
And Laura, that's enough.
That's enough? All right, well, we love you. It's all right.
I love
and so,
I'm nice to children.
But thank you, Tracy. We're so excited to have you here.
I'm very happy to be here. Now let's see if I can master the clicker. Okay. So, oh yes, no, that's the wrong way. Okay. All right, so shall I get started? And Laura, you'll give me a signal when I need to speed things up? Okay, so I'm here to talk about how open source reference designs accelerate commercial adoption. But before I do that, I'll give a little background about the O-RAN Alliance. I think everybody's heard of the O-RAN Alliance by now. Just, level set, what is the vision, and what is the O-RAN Alliance? Is it a project? Is it a standards development organization? Is it a little bit of both? I'll also talk a little bit about the open source focus group within the O-RAN Alliance. I'm one of the co-chairs. I'm hoping to persuade our colleagues in srsRAN to get more involved in the reincarnation of the super wireless blueprint. I'll give a few examples of how we're using open source to accelerate work that's taking place right now within the NTIA Public Wireless Supply Chain Innovation Fund Testing and Evaluation Project Accord, as well as within the NSF DoD Convergence Accelerator Project, and of course some things that we're doing AT&T internally. So hopefully that will amuse and inspire everybody. There will be questions and we'll keep it kind of interactive. Oh, I did it. See, I got a problem with clicking. Okay, so, that's better. Oh, no, it's going to mess up clicking. Okay. Okay, so O-RAN, of course, the O-RAN Alliance has been around for a while. It was established as a German entity in 2018. It was formed from merging China Mobile srsRAN Alliance with XRAN Foundation. XRAN Foundation deserves most of the credit for open front haul. We've got lots of, there are 5 founding members. I'm very proud that AT&T is among the 5 founding members. I knew this was going to be a problem. Okay. And of course, the mission is pretty clear. We want to open up the proprietary interfaces. We want to disaggregate. We want to virtualize. We want to AI enable and make things smart. And most significantly, we want to achieve multi-vendor interoperability. Now, we've done some good work, but we're not there yet. And one of the reasons we're not there yet is we don't yet have a reference design that consists of commercial products end to end. I'll talk a little more about how we're very much dependent upon let's call it a set or a library of open source reference designs that make it easy for us to evolve component X while the other components are still in the incubator. So we now have, we might be a little too big for our own good. It takes quite a while to get consensus with respect to anything that we try to do. However, we are a marvelously diverse community. You'll see almost A to Z. Academia, Virginia Tech is an O-RAN member, as well as one of the O-RAN Open Testing Integration Centers in North America. Application developers, I think some are here. Obviously, cloud providers, very important government agencies. The ORAN Alliance got about as far as it's going to get with unpaid volunteers, and we are deeply grateful for the generous support of NTIA Public Supply Chain Wireless Innovation Fund, as well as the National Science Foundation, just to name a few. But again, because the ORAN ecosystem is everybody, there are some work items that don't belong in the ORAN Alliance. Anything that is a matter of national security can and should get, again, I like the word incubated in the ORAN Alliance, but we need a place to do more research and development, do maybe a specification that is not made available globally. We are very much committed to global reach and global collaboration and cooperation, but we're also mindful of geopolitics, unfortunately. So, 3 main thrusts. There's the ORAN specification effort, and that's kind of ORAN as a standards development organization. What I like about the ORAN specification effort is we have a liaison statement with 3GPP, so when we learn something and issue a specification, we work with 3GPP so that we remain in sync. Insofar as possible. There are a few areas where that's not the case. Testing, integration, and certification. This is the ORAN Alliance as a project, which is a good thing. Specifications are rather pointless unless they're implemented, and a lot of the specifications can't be implemented because of, we have open model-driven APIs without an open model. For the longest time, we talked about, in the ORAN software community, all the work that we would do, and we had RIC and non-real-time RIC and near real-time RIC, and we had everything except an open CUDU. Well, that's no longer the case. I was here last October. I was very encouraged by what srsRAN is doing. You'll see in a subsequent slide, I said, oh, srsRAN will be at our demo in the face-to-face meeting in Montreal in late October, November, or in spring of 2025. It's up to you, Paul and team. So there are lots of different groups within the ORAN Alliance. You'll see open source focus group. As I already mentioned, I'm one of the co-chairs within the open source focus group, but each focus group cooperates with the other focus groups or butts heads with the other focus groups, and we all work collaboratively with each of the working groups. I'm not going to go into those because you'll have the slides. So open source endeavor. Ooh, this got a little messed up. So the open source focus group is specifically chartered to develop open source strategy, address relevant issues, requirements. One of my favorites is licenses. I didn't realize how, they say that, Canadians, Australians, and Americans are separated by a common language. Well, open source communities are separated by a so-called common licensing approach. It's a big problem. But we're working on that, and I have more information about that. ORAN software community was established by the open source focus group, and it's done a lot of really good work, mostly taking Linux Foundation networking components and packaging them. So for example, if you look at what the ORAN software community has done so far with the ORAN specification consistent, not compliant, I don't like the word compliant, service management orchestration framework, it's very much based on Open Daylight for non-real-time RIC and ONAP for the ONAP, the Open Network Automation Platform, which is also something that AT&T spearheaded. So we've done a lot of good work in both the O-RAN Alliance, the Open Source Focus Group, the O-RAN software community, but again, not sufficient. Finally, as I was saying, we have this notion of a OCU, ODU, down in the lower right-hand corner of this slide that could have an srsRAN logo next to it. Okay. We'll talk a little more about what Open Source Focus Group has accomplished, what remains to be done, and why we are speeding things up, not only because we need open source reference designs to succeed with the NTIA Accord project, and we're also dependent upon open source reference designs for an NSF project called Securely Operating Through 5G Infrastructure TRACK-G, which is in the Technology Innovation Partnership Directorate that AJ, I know a lot of AJs, SJ was talking about. So one problem is standards take forever. Now, the standards that are the slowest to evolve, typically because they're the most in the flux, are the most exciting futuristic features, right? And this ranges everything from real end-to-end slicing. I like to call it subnet-aware slicing, as well as anything that you can do with AI enablement and programmability end-to-end, all of which represent significant security risks. So this is not going to get commercialized as quickly as anybody wants it to get commercialized. We can't wait for formal approval and widespread adoption of standards that are, have the seal of approval from the O-RAN Alliance or 3GPP. We've got to do it. We used to call it take the open source first approach and deliver a software-driven standard. And of course, that's all about continuous integration, continuous delivery, continuous testing, and it's a loop. You figure out, you model something, somebody writes some code, you have a simple use case, you try it out, you learn from what works and what doesn't work, wash, rinse, repeat. We need to get back to that. And again, that approach very much depends upon not spaghetti code open source, but open source that is, rigorously quality controlled, maintained, release managed. Again, a library of open source reference designs specifically intended to support basic testing, but also research and development teams, and make sure we can get reproducible results. Now, one of the reasons why we don't have any certificates or badges yet from any of the efforts in the O-RAN Alliance is it's been almost impossible to get reproducible results. Very important to have a very, I almost want to say carrier grade, but that makes me sound like a telecom dinosaur. But that's what, I think I have a couple colleagues from Verizon here. I haven't seen them. But that's what we're looking for, quite honestly. And we've got open source all over our network, whether it's wireline. You can even think of, if you want to, and I think this is valid, go as far back as common language standards. That is, I'm not sure if I would call it open source, but if you refactored it as a Yang model or a set of Yang models, you could call it open source. The old days when we had common language facility, common language location, common language circuit identifiers. So building upon what DARPA started, DARPA had this program called Open Programmable Secure 5G, and it came out right when the COVID came out. So it kind of got a little sick early, even though it recovered. And great stuff in Linux Foundation networking with a 5G super blueprint, super wireless blueprint. We want to take it to the next level and make it the open 5G, NextG, super wireless blueprint that would probably also include cloud. And this is, when I say we're talking to our friends and co-conspirators in Linux Foundation and Linux Foundation networking. We were talking to ONF, but then ARPIT absorbed ONF, so we don't have to talk to ONF anymore because they're now part of Linux Foundation. Obviously the ORAN Alliance, Open Air Interface, and guess who else? srsRAN. So I know there will be challenges to bring this all together, but ideally, we said this last year, Paul, you may remember, we'll be in a position to have a disaggregated, virtualized, mostly open source with guardrails, CU from srsRAN, interoperating with a disaggregated, virtualized, mostly open source DU from either a vendor or OAI. And I know that you told me last year you guys are already working on some of the interfaces to SMO components. Again, SMO is Service Management Orchestration Framework. So yeah, I'm very optimistic that we'll see a super wireless blueprint that will actually have RAN, and that'll be great. And RAN capable, CU, DU, open source CU, DU that we can use in this test bed, which is one of the Accord test beds, one of the most important Accord test beds because of the reputation of this institution as well as where it's situated in the Washington, D.C. metro area. We'll be able to have a open source or mostly open source CU, DU to use to test all of the ORUs that come our way. And it'll speed things up incredibly. If we're testing M-plane, management plane, we can do it over the public internet, secure connection over the public internet, run the tests, test automation. Where's Ian? Ian's back there. Biabi's going to help us with test automation. And within minutes, produce a report that says not only what passed or failed, but what the results were in a way that's machine readable. So that's the vision, and you probably think, why do operators care about this? Well, it costs us $1 gazillion to test, upgrade, test single vendor stack 5G systems, and then the whole ball of wax. Think about what it's going to be when we have, and we're going to have, right now we have single vendor stack Ericsson, single vendor stack Samsung, single vendor stack Nokia. Whether you look at the two, biggest mobile network operators, two bigger mobile network operators in the United States. Soon we're going to have single vendor base station with ORUs, radios, that are consistent with the ORAN working group for open fronthaul specification, introduced incrementally. And they're all going to have their own release management, their own release plan, and at the same time, the working group for open fronthaul specification will be evolving. So keeping that keeping that up to date, lifecycle managing that is going to be hugely expensive, very time consuming. We need to automate. We need to probably outsource quite a lot of it, and we need open source. Okay, so last but not least, open source makes everything more portable. You decouple the hardware and the software ecosystems, and then you make it easier to introduce innovative hardware. And this may sound weird, but that paradoxically also accelerates commercialization. Otherwise, you're waiting around for special purpose hardware. Here, innovative hardware that does something that generic stuff doesn't do. Everything else is software. And software is, again, starts open source. We're all in favor of commercializing, because if you don't commercialize, if people aren't making money, you don't have a sustainability plan. So we're not saying open source because we want freebies. So, oops. Did I go backwards again? Okay. So what we've done so far, we have a white paper and a roadmap Those of you who are ORAN Alliance members can see that on the ORAN Alliance wiki. I'd be the first to confess that every quarter we push out the target date for a stable draft, so now we're pushed it out to fourth quarter 2024. We're building upon, as I said before, what we've already accomplished in the ORAN software community, as well as the 5G Super Blueprint, Linux Foundation Networking. That's based on DARPA, Open Programmable Secure 5G, and you know, requirements in a roadmap from ORAN. NSF is actually providing requirements in a roadmap because of some of the projects that call out in abundant clarity, what, like spectrum, dynamic spectrum sharing has moved to the front of the line for a lot of excellent reasons, and that's guiding and informing how we build out this, let's call it Super Blueprint 2.0. Some of that will be use case driven, and the use cases we're using to drive it are dynamic spectrum sharing, as well as spectrum coexistence, which are quite different, energy, spectrum efficiency, break-even points, things like that. So we're starting with integrating models and code from OAI. There's at present a memorandum of understanding between the ORAN Alliance and OAI. We'd like to explore putting in place a memorandum of understanding with ORAN Alliance and srsRAN. Once we get some models and code and components, we can't ignore cloud, hence Nefio. And you already see I have srsRAN mentioned here. Our focus will be on ORAN Alliance. Now, MVP means a lot of things. This particular use of MVP is not minimum viable profile or minimum viable plan or minimum viable product. It's minimum viable package. So let's say we have this killer use case, dynamic spectrum sharing, and to get it to work, we need, again, component A, srsRAN, component B, Nefio, component C, OAI. That would be the package for hypothetical killer dynamic spectrum sharing use case. So we've done OSC, OAI demonstrations of increasing complexity for like almost a year now, and we are eager to start that exercise with you guys. We've had joint open RAN software community, open source focus group, OAI workshops. We've had preliminary discussions with srsRAN, and here we are today for the second consecutive year at the srsRAN project workshop, Virginia Tech, Oktoberfest. So hopefully when we reconvene October 2025, we'll be able to talk about some of the interesting proofs of concepts and use cases, et cetera, and be farther along than we are right now. So our initial iteration of the simplified is real simple. You have a SMO, you don't get too concerned about all of the service management orchestration componentry. You can make this so complex it'll collapse under its own weight. The SMO is based on ONAP, which has been around for a while. Non-real-time RIC is based on Open Daylight. Near real-time RIC, my favorite word, is still aspirational. And then you don't get too hung up on core. Just focus on the ODU and the OCU. Right now we're using OAI in this diagram, and 5G core is whatever open, you pick your open source core. So the super complicated open source reference architecture service management orchestration framework is this mess that you see on this slide. And there is a roadmap in progress. Of course, the white paper that describes it is also in progress. So it's we have deliverables as well, so that we can keep things moving. And then, of course, our open source reference architecture for RAN. Well, this slide speaks for itself. We're very interested in making sure, you know, we don't want to have single vendor, single supplier anything. We don't want single vendor, single supplier radios or test measurement software or open source CUDU. We want a vibrant ecosystem. So a few examples of how open source reference designs, a new acronym, OSRDs, accelerate commercial adoption. Well, most obviously, and I borrowed this beautiful end-to-end diagram from Spirent with their permission. We don't want to do the kind of testing that the O-RAN Alliance has been doing for too long. You know, testing and retesting open frontal, plugging in vendor A DU with vendor B RU, and making sure that you can execute the relevant test cases from a working group for O-RAN Alliance, of course, test specification. We've been doing this over and over again. And it's worthwhile, except the reality is that the specification is lousy with things that are optional or maybe optional or conditional based on X. And I mean, don't get me wrong, Working Group 4, I think, has done the best job of any working group in the O-RAN Alliance, but you know, conformance testing is not going to persuade AT&T or Verizon or anybody to bring in open frontal, to bring in third-party radios with a dominant incumbent vendor base station. What's going to do it is end-to-end testing and slowly but surely proving, and I said this last year, Paul, performance, feature, resilience, security, parity. So one of the things we're looking to do in Accord test beds, and of course we're sitting in Accord and an Accord test bed, or we're co-located with an Accord test bed, is again, have an end-to-end set of end-to-end reference designs so we can move beyond conformance, you know, RU-DU interoperability testing, and move toward, and not conformance, but end-to-end performance, as well as some use case-driven end-to-end testing. I mean, I think everybody in the room knows if we don't start demonstrating energy efficiency of Open RAN technologies and various deployment options, the party's over. So you can't do that without not only an end-to-end, an end-to-end reference, I don't want to say architecture, reference design, as well as open source simulators and emulators. Because if you get, we don't have all the commercial products, and even if we did, we need to be open so that it's fair, reasonable, and non-discriminatory. We always talk about that from a licensing perspective, but we need to be fair to all members of the ecosystem. Because right now we only have 3 vendors we can buy from in North America. That's got to expand rapidly. Expanding vendor diversity in open 5G NXG RAN is, it's got to happen not 5 years, within the next 1 or 2 years. So that's one reason why we need open source. Oops, sorry, I'm really, really left-handed, so holding the mic means I have the clicker in the right hand, so it's like, ooh, okay. We've been talking about, lab as a service and bring your own device, bring your own software. I mean, ideally we would have, Aloysio's team would have, library of open source reference designs to test use case X, whatever that is. Use case dynamic spectrum sharing, because that's on everybody's mind. And we would say, great, if you have a radio, bring your radio, plug it in, test it against this reference design that may or may not have commercial CUDU may have srsRAN CUDU or OAI CUDU, and let's see how it performs end to end. And repeat, again, take somebody else's radio. You've controlled all the variables end to end except for the radio in this specific use case. What do you get? A lot of that is going to be, a lot of that's going to be performance measurements, but there are lots of other interesting experiments that you can conduct if you control all the variables with radio 1 versus radio 2 versus radio 3 versus radio 4. And that's just the most obvious, simplest example. Doing this, and we've been doing this in the ORAN Alliance proof of concepts and plugfests. We build up a test bed. We do something cool. We pat ourselves on the back. We publish a press release, tear down the test bed. Nobody can ever do it again. So, developing our apps. This is it's part thought experiment and real experiment within the NSF Convergence Accelerator project, securely operating through 5G infrastructure. We're saying, well, what happens if there's a civilian disaster and you've got operators in a geographic area with overlapping coverage, and they're all dead because operator A, for the sake of argument, lost its DUs. Operator B lost their RUs. Operator C lost something else. Is there a way to, only in the event of a civilian disaster, add a multi-operator service management orchestration layer, let's call it, FEMA SMO or FirstNet SMO or Department of Homeland Security SMO, and orchestrate across all of these non-cooperative subtending networks, basically transforming them into a cooperative network end-to-end, and then use our apps that will figure out exactly what the mission is. Maybe the mission is, go over to, wherever and fetch the head trauma victims first and get them to a head trauma center. That's the mission. And there's geography involved, which operators have overlapping coverage in that area, which of them have network resources that survived the civilian disaster, how fast can you cobble it together and issue a service level specification, provision a slice, et cetera, et cetera. So these Mission R apps that we're developing, they're all being developed with open source software and open source simulators and emulators. Now the goal, of course, is use open source software, simulators, and emulators to go from a low fidelity prototype to a higher technical readiness level prototype. Once you're there, introduce real commercial products. Same thing with this Resilience R app. We're using the Dan Massey definition of resilience. High, medium, low. Is it high, super duper resilient? You need 4 completely diverse paths, 1 3GPP, 1 non-3GPP, 1 satellite, and 1 something else. And you need to be able to, send the message, the transmission over each path and assemble it at the end. And if you lose any of the, 3 out of 4, but only one of the 4 paths survives, then the message will get through. So again, doing this with commercial products or hardware, software, it's just not happening. You have to get it to work with open source, and then our ambition, and this is also aspirational, is we'll hightail it up to Idaho National Labs, where they have this indoor-outdoor 5G test range, and they do a lot of cool things with satellite, and we'll get it to work in the wild with at least some real, a real network, and hopefully satellite and something else. And if the Idaho National Lab doesn't make that possible, we'll go to an Accord test bed. Maybe the outdoor test bed in, I always forget if it's Blacksburg or Blacksburg.
Blacksburg is Struggles Creek.
All right, okay. I know that's up the road a piece or down the road a piece, but we're going to make a site visit very soon if you'll extend the hospitality. Last but not least, the security R app. Again, simple, high, medium, low. The mission commander, whether it's a civilian disaster or it's a military incident, needs to say, well, I'm fine with best effort, low security. Or I want, I'm looking at the catalog of zero trust capabilities as specified by NIST, and I want this one, and that one. That's medium. Or I want everything. And if I can't get everything, maybe I will, maybe I won't downgrade to medium, everything being high. And if medium doesn't work, maybe I just will shut down and use something other than the indigenous network, because it's that important that security be super secure. So doing all of this and bringing together the apps, and again, it's multi-subnet. It's not just RAN. You'll see we have multipath controller. We've got Wi-Fi as an example of non-3GPP. There's a lot to a 5G next-G system. It's all three subnets, and you can't have any notion of resilience unless or you can't slice and have a slice that can have some, I won't say measurable because I don't know if there's really a way to measure multi-subnet resilience yet, but some characterization of it unless you're slicing across all three subnets. Oops. Okay, dynamic spectrum sharing. We've already talked about this. You have a use case. Here we're using a cellular network in receive mode, and we're detecting high priority transmissions, doesn't matter who they're from, and we're using commercial spectrum. Obviously this is a use case from AT&T. We're going to figure out some reasonable mitigation mechanisms so that we protect the priority critical systems if something is going on. And something could be not malicious, something could just be you're running out of capacity. You're experiencing interference that is, if we succeed with dynamic spectrum sharing, there will be interference. We have to learn to love interference. We have to learn how to detect it, mitigate it, and move on. And then you want to keep monitoring this and reinitiate the cellular transmissions, the lower priority stuff, once the higher priority critical use case has served its purpose. So this is a research problem, and the research problem is, what exactly do you need to get from the ORU that you need to extract from the raw data and take into consideration. It's not always clear. I mean, we've got data everywhere, and I was going to say, not a thought to drink. Okay, I won't say that. But it's, you want to be fast. These near real-time RIC is supposed to be within milliseconds, so you can't deal with all of this extraneous data. You have to zero in on the minimum, just the bare minimum data to make whatever decision you need to make. What protocol enhancements are needed in ORAN specifications? Quite a few, actually. ORAN specifications in this area are largely underspecified. And what enhancements to the control plane? Again, quite a few. ORAN specifications are largely underspecified. Doesn't mean they're bad, it just means they're not grown up yet. So let me, real quick, I'm going to talk problems with, copyright. This is, you can read this later, licensing. It is such a hassle. ORAN Alliance and 3GPP work hand in glove. We have a liaison statement, but we can't use each other's code or models other than for experimental purposes. That's being addressed through a standards collaboration copyright license, a license to get licenses to be compatible with each other. How crazy is that? And it's not going to happen until, 2025. I think, yep. I don't know why these slides got messed up. Probably converting them to a PDF. So we've been working on this since 2023. Last but not least, getting the skilled workforce of the future up to speed. We don't have enough hardware, software to throw at this problem. We need to have an educational kit for whether it's undergraduates, graduate students, gifted and talented high school students. We need to develop not just 1, but 5 areas of expertise: software, hardware, test measurements, methodologies, cloud, and standards. This is so much bigger than what a technician or a new, an entry-level type employee would have to know in the single vendor stack world. So this absolutely necessitates open source so that our students can see what's really going on. They can learn on software-defined radios instead of learning by memorizing a vendor's manual, because we don't want to read the manual. No, I'm sorry, I didn't mean that. But seriously, we don't want to create, single vendor experts. We've got a bunch of guys who can fix anything so long as it's all vendor X. But if you bring them in a multi-vendor world, they fall apart. Not because they're stupid, they've just never had the opportunity to, take things apart and look under the hood. Another actually one of the most important reasons for maintaining this library of open source reference designs to help AT&T, because everybody wants to help AT&T, but also to help educators and the workforce of the future. Thank you very much. I think I'm all right.